Hey guys, so today is March the 26th, and I'm gonna do another Leak Code Daily Challenge. Um, yeah, yesterday I wasn't able to do that one, so hopefully we could do today's. Yeah, we'll see. Okay. 2780, minimum index of a valid split. An element x of an integer array of length m is dominant if more than half the elements of array have a value of x. You are given a zero index integer array nums of length n with one dominant element. You can split nums at an index I into two arrays, 0 to I and then I plus 1 to the end. But the split is only valid if 0 less than or equal to I less than n minus 1. Yeah, just I just needs to be, yeah. I just needs to be in the index, right? Num 0 to I and I plus 1 have the same dominant element. Hence, nums I to j denotes the subarray of nums starting at I and ending at j. Both ends being inclusive, particularly if j is less than I, then nums I to j denotes an empty subarray. Return the minimum index of valid split. If no valid split exists, returns negative 1. We can split the array at index 2 to obtain the array. Okay, I feel like I just need to write stuff out, or like at least draw things out to make it more easier to understand. And then I just draw out the example 1 should be chill. So we can split the array at index 2. 0, 1, 2, 3. They're saying let's split the index right here and obtain these subarrays 1, 2, 2 over here, and then this subarray is just 2. In this first one, element 2 is dominant since it occurs twice in the array, and 2 times 2 is greater than 3. Oh, I see, I see. In array 2, the element is dominant since it occurs once in the array, and 1 times 2 is greater than 1. If it's a valid split, it can be shown that index 2 is the minimum index of Hmm. My only concern or my only question is if we have this as an array, why can't we just split it right here? So we're going to be comparing, oh, 1 and then 2. Even though the 1 is dominant, this one 2 is dominant, but 1 does not equal 2. They have to have the same dominant. Interesting. And honestly, I have no clue. I feel like maybe it's like some sort of line sweep problem, but I don't really know sweep line stuff. I'm not sure. Let me look at example 2. Maybe I could find something. Um, okay, so we can split the array at index 4, 0, 1, 2, 3, 4. So that means we have two arrays like this. One is dominant. Okay. Sorry. Maybe like this is like an array type problem, obviously. Maybe I could categorize it more into it's definitely like an array type problem. Maybe even some type of sorting, right? Because I kind of see that we might need to sort these. So like now that we have two separate arrays, let's sort this one. So it'll be like 1, 1, 1, 2, 3. Right? They're all different. And then if we take the median, the middle, does it work like that? What if it was 1, 1, 2, 2, 3? Oh, nums has exactly one dominant element. 1, 1, 2. If it has exactly one dominant element. Hmm. Like I remember yesterday's problem, there was a lot of stuff about median in like the middle of the array. There's a lot of properties that I don't really know. And I feel like this problem might be like that. Like, is that really the dominant? Wait, how do they test for dominance? One, two, three, four, five, and then you just say how much. Like the frequency, 2 times 2 needs to be greater than the length. Oh, it wouldn't even be this. It needs to be more than half. Yeah, so it's not just the median. I'm thinking of a solution that it will probably be too slow, but I guess it is what it is. So if we sort like the left side, we're going to get 1, 1, 1, 2, 3. Then we could just count, right? Because we know the size of the array. So we have a goal. Dominant is when more than half the elements of this array, so 1, 2, 3, 4, 5. So we're looking for 3. If we could, I guess, look from left to right. If we ever find something that appears 3 times, then we're just going to return that as the maximum. So for this one, we know that 1 appears 3 times, so we're going to return 1. So 1 is the dominant on this left side. And then for the right side, if we sorted this, it's 1, 1, 1, 2, 7. Again, we can do that thing where we just look from left to right, trying to find like 3 occurrence. 3 consecutive. Once we see 3 consecutive, we're just going to return 1, and then we could just compare these ones. I feel like it might not be fast enough though. This is like n squared, and I don't think n squared would work for 10 to the 5th. Okay. Also, how do I know where to start? Do we just like start checking this first, then this, then this? That's n. That's literally n squared. Yeah, okay, I don't know. N squared's not gonna work. Okay. Let's take a step back. I'm not gonna explore something that I know is just BS, right? Like, that's not gonna work. Maybe we can do better in the sense of almost like a sliding window or like a prefix sum idea where we do look from left to right, or maybe we have like 2 pointers, a left and a right. um Basically what I'm thinking is maybe some sort of hash map might be cool. And then maybe in the beginning, or it's going to like take care of the frequency. In the beginning, we just look through all of them. Kind of like if we were like summing it, like those like arrays and like the subarray sums, we always want to start out with the total sum. In this case, maybe we just take the total frequency. So 1 appears 1, 2, 3, 4, 5, 6 times. 2 appears twice. 3 appears once. And then 7 appears once. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 8, 9, 10. Okay, cool. So this is our frequency hash map for now, and it's taking care of everything. So now let's just say that we split right here. We would maybe this represents the right portion because it's already done, right? And then maybe the blue would represent the left portion. So that's okay. So this is the right portion, and then in the blue, we're just going to represent some sort of left portion, which makes sure we remove it from right first. So when we're at this index, maybe we could call it like the split. I don't know. It's just one index that we're traversing, right? So we just need to keep track of it. Maybe I. Remove I from right. And so since it's 2, we just subtract 2 by 1. So this becomes 1. And then we need to add 2 over here. So 2 appears once. Okay. Um, how do we calculate the max frequency? Do we really just need to run through the entire hash map? That would be inefficient. Maybe we even need to store this in maybe like wow, this is crazy. Maybe we need to use a max heap where this is going to be the frequency and then this is going to be the value. But max heap, we can't search through the whole thing. Like, what if we need to remove a number? Like, how do we know to update our max heap? Okay, maybe I'll scratch this max heap idea for now. I'm kind of lost. Anyways, 2, 1. I guess we'll just have to traverse all of the values in the map, trying to find a value that's greater than like half of it, the frequency that's greater than the length of half. And let's just say this didn't work. So this one would return, this left half would return 2, and then this right half would return 1. Those are obviously not equal. So we would move on. Now we're going to this, this one, and then our left would now expand, and our right would be this, which means we need to remove 1 from the right, so this becomes 5, and then we need to add 1, which isn't in here. We need to add the frequency of 1. Oh, and in this case, since I is at 1, we have a length of 2. We want to find something that is greater than 1. And since we can't find that, we'll just continue. Okay, I'll just start coding it. I feel like it might actually not be efficient either, but we'll see. So this is some like array um, hash map stuff. We want to just like pre-process the right portion. Um, right. Uh, the right frequency is a default dict int where the key is the like it's like the number, the val is the frequency. We're definitely gonna have a left frequency too, so I might as well just put that down. For n in nums. Right frequency at n plus equal to 1, so we up the count, right? Cool. Then we want I to be 0, so this is the index. And we just want to run, I guess we don't need to explicitly call that. We just want to run for I in range n is the length of nums for I in range n. Let's start over. If this was I, so we just start processing all the way up to I. So our left portion is from 0 to I, and then our right portion is from I plus 1 to n minus 1. Which means, I guess, like if we're thinking farther ahead, what if our I was right here? Or what if our I was at the very end? That wouldn't make sense, right? Because the right portion would be empty. So I think we want to stop when we get to n minus 1. So when we get to n minus 2, I meant. So let's just go to n minus 1 is our last thing. Okay. Yeah, that should be fine. So left portion is from 0 to I, which means we want to add our nums at I into the left frequency. Left frequency at nums I plus equals to 1. And then I guess we want to remove nums I from the right frequency, nums I minus equal to 1. I don't like that I have to now, since we're just removing one thing, why do we still need to traverse the whole array? That's not efficient. I mean, we have to look at every single element in the hash map. I still think we might need maybe like a max frequency or something. Max frequency for the left, max frequency for the right, and these will just be 0 to begin with. Ah, I'll think about it when it fails, I guess. I don't know. So we remove it. So now we just check. What's our goal? Target is our target frequency is find dominant for left. The target frequency is I plus 1 divided by 2. So if it was 1, that's 1 divided by 2 is 0. So we want something greater than 0. Okay, if our I was at 1, it would be something greater than 1. Yeah. Okay, so this is our target frequency is equal to I plus 1 divided by 2. That's the target left frequency. For value in left frequency, if left frequency at V greater than target left frequency. Left dominant is none. If it's greater than this, left dom is equal to V, and then we just break, because we just need to find the first dominant. Or if it's greater than half, that means that's the only dominant one. If left dominant is equal to none, then we shouldn't even process the right. We should just continue. Okay. Otherwise, find dominant for the right. So the right dominant is none. Target right frequency is... what is the target right frequency? So if this is an example, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the index 9. Is there 7? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 things, and we're at index 1. So 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10 minus 1, which is 9. And minus I divided by 2, something like this. Let me just double check. What if this was my n? So 9, 0, 1, 2, 3, 4. Let's just say our I was currently at 4. So we do 9 minus 4, which is 5, divided by 2, which is 2. Yeah, and we want it to be greater than 2, so that means at least 3. I think that works. We'll just n minus 1. Okay, that's fine. I'll just stick with that for now. For V in right frequency, if the right frequency at V greater than the target right frequency, right dom V break if left dom equals right dom, return I. They want the smallest index. And then if none of it works, right, it's possible that nothing works. So we just return -1. Oh, if left dom is equal to right dom, that's in the same one. Otherwise, after we loop through everything, we just return -1. So you run this. This should work. Oh, I was doing 9 minus something, right? But n was 10. So it needs to be, sorry, the right is n minus I minus 1, I believe. Let me run that. Oh. Is the indent wrong? No. Okay, that's weird. Let me just print the iteration left dom, right dom. I'm gonna start with that. Yeah, that makes sense. The left dominant is 1, there's 2. That's good. Okay. But then shouldn't it go for I in range n minus 1? So now it should do this one, right? Whoa, whoa, whoa. What is n? Oh, n is 2. Why is n 2? Dude, I'm using some really bad stuff. I don't know why I'm reusing that. It shouldn't be like that. Okay. Oh. Yeah, that works. I'm gonna submit this, but I don't think it's fast enough, and then I guess we'll figure that out later. Yeah, not fast enough. It's a lot of repeated work. I like the idea that we're just keeping track of like hash maps. I think that's good so that we don't have to re-look through things. The more I think about it, the more we should be using a max heap. But I don't know how we can maintain the maintain the stuff in the max heap. Oh, 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 oh. This is very interesting actually. Okay, wait. I might need to take one more step back. If we have an array where I know how to find dominant, right? It actually is the middle of an array. Because um if you have like this many values in an array and you want more than half of them to be the same, let's just say that was like a 5, right? So all of these all the way to the midpoint and beyond. So more than half of them would be a 5 no matter what. The rest would be like some other stuff. We just need to take the median. We know the median is the thing. But in order for this to work, we need to make sure that it's sorted. So instead of splitting the array and then sorting it, maybe we could use some sort of like bisect or like binary search to just maintain like two arrays, and then we like add to it and take away from it, but make sure we add it to a very add it to a very good spot. Yeah, so okay, that was cool that I thought about this like heap stuff, but actually it's sorting and then maybe even like a binary search just to find indices. So no more frequency, no more frequency stuff. That's not gonna work. No hash map. It's like array, maybe some sorting. So this is true, right? Okay, we don't need the right frequency. Or maybe we do need to process the right portion. That does mean that is true, but it's not. We're not using a frequency anymore. Um, n log n is fine. So we just need to sort the array. Sorted nums. That's just going to be our right section, and then our left section is just going to be, I guess, empty for now. So add our nums I into the left, which makes sense. Um, I don't know. Is there something like add to a sorted list? Like insert into sorted list Python? Because I don't know. So there is insert. And there is an insert. Okay, maybe I could use the insert. Um, the index is bisect left. Trying to go left with a. I'm sorry. What if there's two things in the array? Okay, yeah, I have no clue. Damn. Hash map, that's my first thought. Yeah, take it away from the first, but then how do we check if it's valid? If first map num, create a split of the current index. If first map at num Oh. So I was almost there. Where's my submission? This submission was almost there. The only thing is that, yeah, we add left and right. The only thing that changed was the frequency. All the other frequencies didn't change, right? The only frequency that changed was this. So that's all that we need to check. We don't need to loop all of this other stuff. So we just need to say if the left frequency at nums I is greater than 2 times I, wait, is 2 times I correct? Remember, I is 1, 2 times 1 is 2. If it's greater than 2, no, 2 times I minus 1. Like if I was here, 0, 1, 2, it would be 4 minus 1 is 3. Oh no, what am I doing? Sorry, wait. I had it earlier. I plus 1 divided by 2. That's what it was. I plus 1 divided by 2. If it's greater than this, and right frequency nums I greater than n minus I minus 1 over 2, return I. Okay. Horrible video. I was like almost there, but yeah, that's sad. I knew something felt kind of off. I guess I deleted everything, but something felt kind of off that even though we're just changing a couple things, why am I looping through the whole like hash map again? Like that just didn't seem right, and it wasn't right. Like if we're just changing the frequency of two things, then all we need to check is those frequencies. We don't have to check anything else because those had already have been processed. Or like those just all maintain the same. The only thing changing in each iteration is the left frequency at nums I and the right frequency at nums I. So that's the only thing we need to check in order to return that index. Anyways, see, okay, so let's do time is, this is n, right? Linear, but then oh, I think it's just linear. Let me see I think it's just linear time, linear space. Yeah, linear time, linear space. No, you could do majority voting for this. How? Hmm. Anyways, thanks for watching. Hopefully I could do better tomorrow. Another failed one. but yeah.